Hello and welcome to our first video for DMA 20, Fractions and Decimals. My name is Dane Peterson. I'm a DMA instructor at CCCC as well as an academic coach with Trio Student Support Services. It's currently the 2016 spring semester, and as of this semester, we'll now have DMA videos for DMAs 10, 20, and 30. We're hoping to produce more for subsequent modules. But let's get to our first video for DMA 20. In section 1, we'll explore an introduction to fractions, and this is part 1 of a 2-part video series. In this first video for section 1, we'll discuss some fraction definitions, then we'll graph some fractions on a number line, and then look at some special fraction forms. In part 2 of section 1, we'll look at equivalent fractions, prime factors of whole numbers, and then simplifying fractions to simplest form. Let's start with some definitions for fractions. The word fraction comes from the Latin word fractio, meaning breaking into pieces. So when we're working with fractions, we're breaking whole numbers apart into pieces of those wholes. Two important definitions we'll start with is the numerator. So the numerator is going to be the number above the fraction bar. So if we look at this example below, 3 here is the numerator. It's on top of our fraction bar here. The denominator is the number below the fraction bar, and it represents the number of parts in a whole. Here, 4 is going to be the denominator. So in this example here, 3/4, the 4 as the denominator tells us that there's 4 parts in a whole. So if we imagine this circle as our whole, it's been broken into 4 parts because the denominator is 4. And 3, the numerator, tells us how many parts we have. If we were to shade this circle to represent this fraction 3/4, we would have to shade in 3 of these 4 pieces of our pie here. So that would represent the fraction 3/4. 3 of those 4 total pieces of that pie have been shaded. Here we'll explore some more definitions. First, a proper fraction, a fraction where the numerator is smaller than the denominator. So the top is going to be smaller than the bottom. And these 3 fractions are all examples of proper fractions. 1/2, the 1 is smaller than the 2. 5/7, -5/7 I should say, where the 5 is smaller than the 7. And then 9/13, the 9 is smaller than the 13 on the bottom. An improper fraction is a fraction where the numerator is larger than the denominator. So in these examples here, we'll see some improper fractions. 3/2, for example, is improper because the numerator 3 is bigger than the bottom number 2. 9/5, 9 is bigger than 5. And -21/10, 21 is bigger than 10. Now we'll explore later on in this DMA 20 that these improper fractions can also be represented as mixed numbers. So we'll get into that more in a later section. Before we move much farther along, I'd like to give you a note about negative fractions. Negative fractions can be written in a variety of different ways. The negative sign can either be written in the numerator, as in this example here, this is -1/2, with the negative sign on the numerator of the fraction. It can also be written in the denominator, as in this example, where the negative sign is on the bottom of our fraction, or it can be written in front of the fraction as this third example. The negative sign is written in front of the 1/2. Now, the middle one you won't see too much, but this one and this one are going to be pretty common. Usually we would just move that to the top or out in front of our fraction, but a negative fraction can be written in those 3 different ways. Next, we'll graph some fractions on a number line. Okay, so let's start with our first example here, 2/3. Now remember, the denominator here, 3, is going to tell us how many parts there are in a whole. Our first whole on our number line, since this is a positive number, is going to be from 0 to 1. So that whole has to be broken up into 3 different parts before we can wrap this fraction. So I'm going to try and break this up into 3 different parts. Okay, so there I've done that. I've got 1, 2, 3 different parts between 0 and 1, so I've broken that whole into 3 different parts. Now 2/3 is going to be 2 of those 3 parts, so I'd move over 1, 2, and 2/3 is going to be plotted right there. We can plot that with a dot, and then let's write that as 2/3. Our next example is -3/4. Now we're negative here, so we're going to be moving to the left of 0. So since our denominator is 4, this first whole from 0 to -1 needs to be broken into 4 parts. So I'll break that up into about 1, 2, 3, and that will be my 4th part. So this whole from 0 to -1 has now been broken into 1, 2, 3, 4 parts there. The -3/4 is going to be the third of those 4 parts, so I'll count over to the left 1, 2, 3, so that will be my point, -3/4. Our last example is going to be 3/2, so let me pick a new color. And we need to break our positives into halves now. So between 0 and 1, the halfway point is going to be here. But let's see what's going on. I need 3/2. 1, 2 will get me to 1, but I need my third, so I also have to break this whole up into halves too. So let's do that. Between 1 and 2, the halfway point is going to be here. So 3/2, this improper fraction, is actually going to be bigger than 1. So this is 1, 2, 3/2. We can plot that right there. So we'll put in our dot, and that's 3/2. So a good thing to note is that our proper fractions, the first ones that we had, the 2/3 and the -3/4, proper fractions are always going to be less than 1, or if they're negative, less than -1. Improper fractions, like 3/2, are always going to be more than 1. Lastly, we're going to look at some special forms of fractions. So let's remember when we're simplifying these what the fraction bar means. All a fraction bar is a division sign. So we could read this as the fraction 12/12, or we could read it as the operation 12 divided by 12. Okay, and whenever we have a number and we divide it by itself, we get the number 1. In the second example, 9/1 is 9 divided by 1. And whenever we have a number divided by 1, we get that number back. So 9 divided by 1, or 9/1, will be 9. So if ever we are simplifying fractions in the future and we get a denominator of 1, we can always just represent that as a whole. Here, 18/0 is our third special fraction that we're going to look at. If you've ever tried to plug a divide by 0 and plug that into a calculator, you probably get an error message. That's because we can't divide by 0. So this fraction 18/0, 18 divided by 0, is said to be undefined. Because we can't divide by 0. However, 0 divided by 18 is defined. This is 0 divided by 18. And we can do this. 0 divided by any number is just what? 0. Now, a lot of students get confused about the 0 being on the top or the bottom, so I'll share a little trick with you that I use to help me remember which is undefined and which is 0. So think of this as we're reading this fraction from top to bottom, okay? And we're going to put our O next to our 0. So here we have 0 on the bottom and 0 on the top. If we have 0 on the bottom, that's a big NO. We can't divide by 0. Okay? But if we have 0 on the top, that's OK. So 0 on the bottom is no reading down, and 0 on the top is OK reading down. And hopefully that trick will help you to remember which fractions are undefined and which are possible but equal 0. So to review, in this video we did some definitions for fractions, proper, improper, numerators, denominators. Then we graphed fractions on a number line, both proper and improper fractions, as well as the negative fractions. And then we explored some special fraction forms. Next up, when we continue talking about Section 1 and DMA 20, we're going to talk about equivalent fractions, both definitions and how to find them, prime factors of whole numbers, and then simplifying fractions.